Hi again folks, how's all doing? In my last layout update I mentioned that I'd been sent a new shuttle unit from Steve at BLOCKsignalling to try out. It's a DC shuttle with acceleration and deceleration. It's the SAS2-BR. Now when Steve very kindly offered to send me this, I mentioned to him that what I would really like a shuttle to be able to do would be to decelerate after crossing a break in the track in such a way as to allow, a DMU to come to a halt slowly, but for that to work, the break in the track would need to be much further away from the stop than I currently have mine set. And for that to work, ideally, the time it takes for the model to decelerate would really need to be adjustable. So when I mentioned this to Steve, he came up with the idea of incorporating a programmable delay time after the locomotive crosses the break in the track. There'll be a programmable amount of time before the deceleration starts. So the rate of deceleration can be programmed, but also the time before it starts to decelerate after passing the break in the track. Now that sounded really good to me because it'll allow me to set up my shuttle and have the DMU slow down and stop at this station in just the right place, and at the other end underneath the hill there I can have it just come to a stop. It doesn't really matter because you can't see it. And I'll also be able to program from each direction coming into the station the rate of deceleration and the point at which it starts to decelerate. So to be able to test it out and figure out how it all worked, I've jury rigged up a test track here, just a straight of track, and it's wired up for a station stop in the middle, as per that diagram there. I've put little traffic cones at each break in the track, just so you can see where the brakes are. So let's turn on the power, and this should slowly pull away, and it should stop just past this traffic cone here. So that's now the first station stop. Now because that's going to be adjustable, I can adjust the rate of deceleration, but also the time at which it starts to decelerate. So I should be able to set it so it stops about there. So this will now go to the other end of the line, past that traffic cone, and then the little LED will flash to tell me it's reversing to change direction, like that. And it goes the other way, and it should stop about there. You can adjust how long it spends at the station and at either end of the track. So there we go, that's it basically working. By turning this control on the right with a screwdriver, you can control the amount of power that's going to the locomotive. So that will vary from locomotive to locomotive, and this controls the time. So if you want it to spend longer at the station or at either end of the track, you can adjust that. So programming it is a little bit fiddly, but it's not something you should have to do very often. But basically what you do is, with the power switched off, you hold in this little button here. It's a tiny little metal button. You hold that in, the LED will flash, and there are a number of different memory modules. So to control the deceleration, I'm looking for memory module 8. So I have to hold this button in until that LED flashes 8 times. And then I release the button. The LED will come on for about 5 seconds and then start flashing again. And the number of flashes determines the entry under that memory module. So if I set this for memory module 8 and then allow a number of flashes, it will increase the deceleration time, in theory. So let's just try it. So to hold that button in, switch on the power and count 8 flashes of the LED. 1, 2, 3, 4, 5, 6, 7, 8. and the LED comes on, and then we'll let it go for 5 flashes. 1, 2, 3, 4, 5, and press it again. So that's now stored. So this should get a little bit further past that second cone this time. You see, just a little bit more, a little bit further. Same in this direction, it should go a bit further beyond the cone. So if I wanted to go a bit further, I just have to program it with a higher value. So in the instructions, there's this list of all the memory modules. There's number 8, deceleration rate. So it's very adjustable. And Steve sent me an email with the additional settings for the delay that he's programmed in. So memory 16, so that'd be 16 flashes of the LED. That's a delay after crossing into the station isolated section arriving from the west end. Default value is 1, meaning no delay, and can be programmed in the range 2 to 250. M17 for arriving at the station from the east end direction, M18 for arriving at the east end isolated section, and M19 for the west end section. So basically what that means, the value that you program in for each of those will determine how long after the break in the track the model will start to decelerate. So if we set a value into memory 16, it should set the deceleration to occur a little bit after the break in the track here. So by adjusting that and the deceleration rate, you should be able to quite precisely stop the locomotive exactly where you want it. So power off, hold the button, switch it on, 1, 2, 3, 4, 14, 15, 16. Let go. And we'll let this flash a few times. So that's increasing the delay. Press it there. And let's see what happens. There you go. So it'd take a bit of trial and error to get it to do exactly what you want it to do, but it does work. And once set, it'll be really good. So there you go, you've seen it working and how it's programmed. I'll put links in the description to the BLOCKsignalling website and to this shuttle in particular. It's simple enough to set up really if you follow the instructions. The programming is not user friendly, but without some kind of fancy computer terminal attached to it, I don't see how else it could be done. And it's not something you have to do a lot. Once it's set, it's set. You can factory reset it and do it again. So yeah, it's fine. So the plan is to install this unit in place of that unit. So I'll need to go on to that soon. It'll be a bit of an operation. Be grovelling underneath the baseboards again, which I hate doing. But I should be able to use some of the existing wiring, but I'm going to have to change the brakes in the track. I'm going to have to put new brakes in, just roughly where that DMU is just now, I think, for this end, and close up the brake that's already there. The station, there are natural brakes at the end of this whole piece of baseboard, but I think I'll put a couple of different brakes in and see how that works out. And the same at this end, I'm going to have to put new brakes in, so there's a bit of work to do. One thing I really don't like doing is soldering wires to track. you know, it's anyone who's done it will tell you it's a bit hit and miss, and if one of those comes loose with the way this is wired up, it will just throw the whole thing into disarray. So I really want these connections to be a lot more reliable than just soldered joints like that. So if I can get away with using some of the existing wiring, I will do, because that's all connected to the track using these, which are nice and reliable. But to make any new connections to the track, I'm not lifting the track, and also to close up the existing brakes in the track, I'll need to bridge them somehow. So what I'm going to do is this: rather than using big clunky power connectors, you stick a fish plate under the track and solder the wire to the fish plate. This is Pico flexible track, which nearly all my straights are made out of. So you can stick the fish plate under there, solder the wire to the fish plate, and that'll supply the power to the track. And where I've got a break in the track, I can just put a fish plate either side of the break and wire it up, and that'll bridge it. Because I just don't trust solder on track at all. So thanks very much again to Steve for sending me this to try out. I really do appreciate it. It's going to bring a lot more interest to the layout once it's installed. It's going to be fun to install, but once it's done and configured, it'll be really good. So thanks very much. Okay folks, catch you later.